Okay, Unit 8, Day 1, graphing trig functions. So today we're going to graph sine, cosine, and tangent. Next time we'll get into graphing cosecant, secant, and cotangent. Okay, so sine and cosine are periodic functions. And a periodic function just means that it repeats at regular intervals. So it just like oscillates. And these are called cycles. These intervals are called cycles. Okay, so trig functions are periodic. A period is the length of a cycle. So that right there is a period. That is one period because that's going to start just repeating after. Okay, and then the amplitude is half the distance between the max and the minimum. So it's the distance from the very middle of this function. Okay, that right there is the amplitude. Okay, first we're going to graph sine. So sine has an amplitude of 1, like just y equals sine of theta has an amplitude of 1 and a period of 2 pi. And the sine wave starts at the origin, so it starts at 0, 0, and it looks like an S. Okay, so sine looks like an S. When you're graphing sine, I want you to remember first, last, and middle point are the same. So my first point is at the origin. My last point is at the end of my period, so it's at 2 pi. My middle point is just halfway between those two, so it's at pi, and those are all the same point. Okay? And then to get this S shape, I'm going to go halfway between the first point and the middle point and go up my amplitude. Then I'm going to go halfway between my middle point and the last point and go down my amplitude. Okay, so I go halfway between those two, go up, halfway between those two, go down one. Now we can just draw that. Sorry, it's kind of squiggly because I did it with my mouse, but that's that S shape I'm talking about. Okay, we also have to draw the left side of this graph. So I went 2 pi that way, so I'm going to go 2 pi backwards. Then the middle point's the same. You go up your amplitude, you go down your amplitude. You just draw that S. Okay, so sine looks like an S. You always start at the origin. First, last, and middle are the same. You go up your amplitude, you go down your amplitude. Okay, cosine looks like a C. It also looks like something else. I'll show you in a second. So here, my amplitude is still 1. My period is 2 pi. So sine and cosine have the same amplitude. They have the same period. They just start at different places. Cosine starts at your amplitude and it ends at your amplitude. Okay, so I'm going to start at 1. And I'm going to end. You go clear to the end of your period at 2 pi, but you're going to go up 1 because we start at our amplitude. Start at our amplitude, end at our amplitude. Go halfway between those two, and you're going to go down twice your amplitude. So my amplitude is 1, which means I'm going to go between those two, and I'm going to go down 2 from the line that they're on. So down 2 right there. Okay, and we can draw that. Cosine kind of looks like ovaries. I know this isn't health class, but I always remember it because cosine looks like ovaries. Sine looks like an S. Cosine kind of looks like a C, but it looks like ovaries more than it looks like a C. Okay, so that's just a way to remember that. You have to have your little ends that kind of go down, all right? Let's draw the left side of this graph. So I'm going to go to negative 2 pi, go to the middle, so negative pi, go down 2, and then I'm going to draw that piece of the graph. Okay, and there's the cosine graph. So sine starts at 0, or starts at your origin. First, last, and middle are the same. You go up and you go down. It looks like an S. Cosine, you start at your amplitude, end at your amplitude, go to the middle, go down twice your amplitude. Those look like ovaries. Okay? Cool. Let's get into actually graphing some where the amplitude changes. So if you're given y equals a sine of b theta, or y equals a cosine of b theta, where theta is in radians, a is your amplitude. The absolute value of a is your amplitude. And the period is 2 pi over whatever your b value is. Okay? So in this first example, my amplitude is 4, my b value is 1. So my a is 4, my b value is 1. So my amplitude is 4, my period is 2 pi over 1, which is 2 pi. Okay, this is sine, so it looks like an S. First, last, and middle are the same. So my first point's at 0, 0. My last point's at 2 pi. My middle point is at pi. Then I'm going to go halfway between the first two, go up my amplitude, halfway between the second two, go down my amplitude. My amplitude is 4, so I'm going clear up to 4. Then I'm going to go at 3 pi over 2, and I'm going to go down 4. And then there's that S shape. Okay, I'm going to do the same thing with this left side of the graph. So first, last, and middle are the same, so negative 2 pi and pi are the same. Then at negative 3 pi halves, I go up 4. At negative pi halves, I go down 4. Finish drawing that S. Cool? Let's do cosine now. So here, my A is 1, my B is 1/2. My amplitude is 1. My period is 2 pi divided by 1/2. When you divide by a fraction, that's the same as flipping that fraction and multiplying. So that's the same as 2 pi times 2 over 1, which is 4 pi. Our graph right here, this only goes to 2 pi. So let's relabel this. So at 2 pi, I'm going to label that 4 pi. Halfway between that is 2 pi, so pi will be labeled 2 pi. Halfway between those two is pi. And then between 2 pi and 4 pi, that's 3 pi. And so I'm going to do the same. I'm just going to reflect those over to the other side. So that's negative 4 pi, negative 3 pi, negative 2 pi, negative pi. Okay? Remember, cosine looks like ovaries. So you start at your amplitude, end at your amplitude. So I'm going to start at 1, and I'm going to end at 1. Then you go to the middle, and you go down twice your amplitude. Draw that out. Okay? And then we have to draw the left side of this graph. So you go to negative 4 pi, go to the middle at negative 2 pi, go down twice your amplitude, and draw that one out. Okay, so there's my cosine graph. Cosine looks like ovaries. Sine looks like an S. I guess you could say cosine looks like a C. Ovaries are funnier. Okay. Let's do this one. So another cosine one. Here my A is 1/2. My B is 3. So my amplitude is 1/2. My period is 2 pi over 3. Now 2 pi over 3 is on this, but it's going to be really ugly if we try to graph this. So again, I'm just going to relabel my graph. So 2 pi is going to become 2 pi over 3. Half of that is 1/3, so that'll be pi over 3. Half of pi over 3 is pi over 6. And then halfway between pi over 3 and 2 pi over 3 is pi over 2. And then let's just reflect those over to this other side. And there are those values. Okay. Again, cosine, start at your amplitude. So my amplitude is 1/2. So I'm going to start right there. That's about 1/2. Then I'm going to end at 1/2 also. Go to the middle, go down twice your amplitude. So twice, 2 times 1/2 is 1. So I'm just going to go down 1. And I'll be right there. Draw my graph. And I also have to do it on the left side. So at 2 pi, and then go down right there, draw that piece of the graph. Okay? Sine. So let's do one more sine one. Now here, my A is 5, my B is 1/3. So my amplitude is 5. My period is 2 pi over 1/3. If you divide by a fraction, it's the same thing as flipping that fraction and multiplying. So that's 2 pi times 3 over 1, which is 6 pi. And again, I'm going to relabel my graphs. You're going to have to relabel almost all your graphs. I apologize, but that's just what we're going to have to do. So 2 pi becomes 6 pi. Pi becomes 3 pi. Pi over 2 becomes 3 pi over 2. And then halfway between 3 pi and 6 pi is 9 pi over 2. And then those all just reflect over to this other side. So that's negative 6 pi, negative pi, 9 pi over 2, negative 3 pi, and negative 3 pi over 2. Okay? And remember, sine, start at your origin, first, last, and middle are the same. So first, last, and middle are the same. Then you go up your amplitude, and you go down your amplitude. So I'm going to go up 5, and I'm going to go down 5. And then you can draw that S. Then we're just going to do the same thing on the left side. So first, last, and middle are the same. Go up your amplitude, go down your amplitude, draw that S. And you're done. Okay, save those next two graphs for class. Okay, tangent now. So tangent is a little bit different. We have asymptotes in tangent. And there's no amplitude. We have a fake amplitude, which I'll talk to you about. But the amplitude is undefined because this graph is going to go north to south. So it's going up and down forever. Okay? And my periods are pi instead of 2 pi. So sine and cosine, the period is 2 pi. Tangent, the period is pi. Okay? And then for my asymptotes, you take your period and you divide it by 2. So here, my period is pi, so I'm just going to do pi divided by 2. That's where my asymptote goes, right there. And then we went that distance to the right. I'm also going to go that distance to the left and draw my other asymptote. And then it's every odd interval. Or you can look and see there are 4 units between there. So I'm going to go 4 more units to the right, draw that, 4 more units to the left, and draw that asymptote. So there's asymptotes all over this graph. There are infinitely many asymptotes. Okay? And then for the tangent function, you always start at 0. And then this is where that fake amplitude comes in. My fake amplitude on this is 1. So I'm going to go to the left, over 1, down 1. To the right, up 1, up 1, to the right 1. And then I can just draw that graph. So it just goes right along those asymptotes. And this just repeats. This repeats on the left side and on the right side. And it repeats throughout this whole graph. If we could zoom this out and see all of it, there would just be all infinitely many lines that are doing this. Okay? Let's get into graphing these a little bit more. So given y equals a tangent of b theta, the period is pi over the absolute value of b, and the asymptotes are odd multiples of pi over 2b, which that's the same thing as the period divided by 2. Same exact thing. Okay, so here I still want you to label your A and your B, but this time our A is our fake amplitude, okay, because we don't really have an amplitude. The amplitude is undefined, so we're just going to call A fake amplitude because it's fake, okay? So our A is 2, our B is 1. So our period is pi over 1, which is pi. I need to find my asymptotes. Asymptotes are period divided by 2. My period is pi, so that's going to be pi halves. So I'm going to have an asymptote right there. I'm going to have it to the left. Then I'm going to have it at 3 pi over 2 and at negative 3 pi over 2. Okay. Tangent always starts at 0. Then my fake amplitude is 2. So I'm going to go to the right, and I'm going to go up 2, and I'm going to go to the left, and I'm going to go down 2. And then you can just draw that line there. And it doesn't touch the amplitude, or not the amplitude, it doesn't touch the asymptote. Sorry, struggling. Doesn't touch the asymptote, it just gets close to it. Okay, and then that just repeats to the left, repeats to the right, repeats, repeats. Okay. Let's do this one. So here, my A is 1, my B is 1/3. So my period is pi over 1/3, which is the same thing as pi times 3 over 1, which is 3 pi. And let's find our asymptote. So our asymptote is the period divided by 2. My period is 3 pi, divide that by 2, so that's just 3 pi over 2. So I'm going to draw an asymptote at 3 pi over 2 and at negative 3 pi over 2. Then I just need to graph this. So I start at 0, 0, always. Always start at 0, 0 until we start like moving these, which will be in a couple lessons. Start at 0, 0. Then my fake amplitude is 1, so I'm going to go halfway between that point and my asymptote. And I'm going to go up 1. Then I'm going to go halfway between that point and the asymptote on the left. And I'm going to go down 1. And then you can just draw that. And here, that's really the only one we can draw. We can draw that little piece of that part of the graph and that little piece of that part of the graph. And we're done. Okay? We're going to save the rest for class. I think there's only like 2 more graphs that we will go through. But remember to take the quiz. I'll see you guys tomorrow. You're awesome. Sorry this was so long.